right? We have seen 4 different presentations today. And I'm sure you agree with me that they're all very insightful and innovative. And the presenters, you've seen them on stage, they are not rocket scientists. They are not regular people like you and I, who have found very creative ways of using geospatial technology to build efficiencies into their day-to-day work. So we kick-started the day with SCDF showing their system that captures key information which are crucial in improving the response times and operational efficiency, and also to ensure the safety of their responders. We also just saw how MPA carried out risk assessment on GIS using multiple sources of data like weather stations, simulated plume dispersions, and the base operational data sets to plan for the best location and time to perform bunkering with minimized risk. We also saw how the fusion of real-time data from AIS feeds provides the added information needed in order to minimize potential damage in the event of a leak incident. So around the world, we also see many other organizations requiring to plan for and respond to emergencies and disasters. Like the top 2 on the left here, which looks at potential impacts from floods, and others using our tools to manage power outages and disasters like hurricanes and tornadoes. We also saw how JTC consolidated data about their land and properties that they manage, as well as their customers, into this centralized, intuitive, and accessible system that they call JMaps. This allows users from different groups in JTC gain easy access to relevant data and also to analysis tools that helps them to enhance their customer service and to improve their operational efficiencies and to also to build collaboration across departments. And globally, we see land management organizations use our system for workflows like cadastral management, taxation and land valuation, and parcel zoning for planning purposes. Lastly, we saw how HDB automated a very manual and labor-intensive process that are prone to human errors and requires you to have very good eyesight. And they did it using our rich geospatial and data access functionalities in our Python library. We also have other developer frameworks available to extend geospatial capabilities, both on the desktop and the server applications. And there are other frameworks that allows you to develop applications that you can access via a web or a mobile platform, and even through game engines. And these resources enable your organization to tailor applications and capabilities that are unique to your business processes and your workflows. And all this is made possible because ArcGIS is designed to operate as an enterprise platform, which is capable of multiple kinds of implementation patterns, and also catering to your specific needs. And the core components of the platform integrate seamlessly with one another, which ensures the ease of data management and sharing, and in distributing the geospatial capabilities across an organization, and promotes collaboration across different user groups. ArcGIS is designed for everyone, whether you are a data scientist, a data editor looking to automate routine tasks, whether you are a geologist or a geospatial professional, or a geography hater turned lover like Joe, or a business user who simply needs to add geospatial context to communicate and collaborate. And it supports a multitude of data formats. It ranges from vector to raster data, from multi-dimensional data like the methanol plume to graph DBs, from structured tabular data to unstructured files and documents. It also includes a variety of web and mobile configurable apps that come out of the box with ArcGIS. So it makes it much quicker and easier to spin up an application without even having to write a single line of code. ArcGIS can be used for a variety of situations, depending on what your story is. It may be about ensuring public safety, or keeping track of the status of your operations, or for keeping your asset or facility in good functioning order, or planning for new infrastructure like utility pipelines and electrical cables. It is enabled by you, to be used by everyone, and made available by the people who are creative and intentional. And we are very proud to be part of the story of our award winners today. And these stories indicate the prevailing trends in how geospatial technology is used. They tell us how our users have evolved in the way that they are using the system. So I'd like to echo what Elizabeth from HDB said earlier, that we used to be using our GIS systems as silos in disconnected environments and working in silos with the data just living in your laptop. And then we move on because we see a growing need to allow that data to be maintained collectively by a group of users, and a need to share the analysis capabilities and the end results to a larger audience. And we do that now using what we call an enterprise GIS system. And today we are talking mostly about moving to the cloud and cloud-first strategies. And what you see on this screen right now are a list of trends that we have observed in the way our client has used GIS. We look at GIS bringing in real-time IoT sensor information into the system, like how MPA has done it. And we look at how our users are automating the technology to bring efficiencies into their workflows. And more with geopolitical instabilities, with a need to connect with multiple organizations, we see a greater need for borderless sharing. And this borderless sharing requires you to share data across different systems and different portals. And the distributed GIS architecture is what you will need to transform the way we work together. So by connecting up systems and portals, so that information, maps, and apps can be shared in a single collaboration space with the tools and services available to coordinate work. One of the platforms that does this very well is Microsoft. If you know Microsoft, you know that you can link people up from different organizations on Teams and federate across organizations for file sharing. With our tight partnership with Microsoft, we have woven our technology into their product suites, like what Casey and Kai showed earlier on, and bring these geospatial capabilities into your everyday apps, the apps that you're so used to working with. It empowers business users who do not regularly use ArcGIS, with the familiar Microsoft tools, and creates this unified mapping experience to promote team synergy across departments. You've just seen that presentation from Kai and Casey earlier that demonstrates some of these applications. And if you'd like to know more, you can visit our booth downstairs for the ArcGIS for Microsoft information. AI continues to be one of the prevailing trends this year, and we know that it's going to gain more and more attention. While the hype right now is on Gen AI and AI assistants, let's not forget the traditional forms of AI that abstracts intelligent information from data sources like imagery, videos, and point clouds. ArcGIS, and we call that GeoAI. So as for Gen AI, ArcGIS remains at the forefront of technology by having AI assistants built into our ArcGIS apps. We saw an example earlier where Casey and Kai showed a demo of how the AI assistant can help generate a survey just by asking a question in natural language, and how you can also quickly find what you need using the doc assistant. And going a little deeper into GeoAI, there can be huge savings in time and resources when we know how to use the models for feature extraction, and for object classification. Change detection using satellite imagery is one of the most common use cases, especially when we have disasters like hurricanes and wildfires. Esri also shares pre-trained models, which you can just download and use within the ArcGIS environment. And more of these models are being made available to support new things like deep learning on oriented imagery and your 3D meshes. We have right now 91 different pre-trained models that you can download to use within ArcGIS. And this number continues to increase on a daily basis. But what really excites me is how easily I can use those models within an ArcGIS configurable app. We saw how in the demo earlier where a GeoAI model is referenced in a Survey 123 form that helps you to automatically extract text from an image and then to populate the answer to a question in the survey. This reduces the human errors in the whole process. And this level of integration brings AI capabilities into the hands of every user, which essentially is what AI assistants try to do. They try to put Gen AI capabilities at your fingertips. Most of the AI assistants are in beta right now, but they'll soon make their way into ArcGIS and into the Microsoft apps as well. Aside from the ones that we showed earlier, you'll be expecting to see AI assistants in ArcGIS Hub and Microsoft Teams. Along the same grain of AI and machine learning, ArcGIS also comes with a comprehensive set of spatial analysis tools that perform analysis like space-time analysis, big data analysis, and spatial statistic analysis. And one of the latest tools that we have is the flood simulation in ArcGIS Pro, which you can see in the animation here. The tool uses a digital terrain model, and on top of it, they would try to simulate the amount of rainfall. And you can see where the water would accumulate and where flooding might occur. This, put into a 3D map, would help you understand the impact of a flood can have on its surrounding infrastructure and allow you to plan for mitigation of the impacts. Link analysis is another way of uncovering deep relationships within your data and to discover new insights. It makes use of a feature entity model of a GraphDB to define relationships between entities. And once you have all of that data populated, the graph is able to traverse multiple layers of relationship to identify linkages that are not easily uncovered in a traditional relational database. And with our drive towards smart cities and townships, we are seeing an exponential increase in the number and types of IoT devices installed around us. It ranges from smart lampposts to smart meters in our homes, from bus location tracking to traffic cams. These devices are constantly bringing and capturing live data. And the value that you see in bringing all of this data into a centralized mapping platform is being able to be notified firsthand when measurements on these devices have gone off the charts. It's also a way to monitor trends over time and space so that corrective actions can be taken to improve negative trends. The video that you see here, I think it has stopped running. Let me try and go back. Yeah, so anyway, the video that was playing earlier on, it's using velocity to monitor trains and subway stations around the airport. You will see in real time where the trains are and when the next trains are arriving. This is important to you as a passenger because you would want to make a decision whether to run or to walk in order to catch the train. In the area of 3D GIS, while this is not new, we are continually improving our 3D capabilities across the platform. There are enhancements made in the 3D feature editing tools and in time enabling our 3D layers. and support for 3D tiles. We see a rise in demand for immersive experiences using AR and VR, as well as game engine integrations that you can use to support facilities management and operations. With our ArcGIS integration into game engines, it is now easier to ensure that the data within your game engine is kept up to date. We have evolved in the area of digital twins from just being a static 3D visualization to a living digital twin that represents its real-world equivalent as near real-time as possible. In support of 3D GIS, generating a 3D mesh of the area of interest through reality mapping helps to kickstart this process of building up a 3D geographical context. Then over that geographical layer, you can put your operational data on top of that. We have here in the middle a video of Stuttgart in Germany, shows how you can use reality mapping to create an up-to-date, photorealistic, and highly accurate representation of a neighborhood, a region, a city, or even an entire country. What's new in reality mapping is being able to feed satellite imagery into the engine to generate the same 3D base map. Drone data capture is another way to generate 3D meshes from captured imagery. Other products that it can produce include true orthos and digital surface models. The video here shows how captured imagery is processed to create this digital terrain model. The beauty in this is that you're building 3D systems of records that you can overlay on top of a 3D base map created from reality mapping so that you can capture changes of your data directly into your 3D GIS. Before I end off today, I hope to leave you with a question. What is your story, and how do you want to tell it? Would your story be to find a way to help reach your sustainability goals faster and with lower cost? Or how can you be more seamless in your integration of your business processes to streamline your workflows? So while you ponder over it, feel free to have a chat with any of us from Esri, and let us help you make new stories with ArcGIS.